So hi everyone, in the last class we have seen about the cleavage and also we have completed the intermediates, different types of intermediates. So today we will study the stability of intermediate, that is the electronic effects. So how many different types of electronic effects? Yesterday I have mentioned there are four main different types of electronic effects. What are they? They are inductive effect, mesomeric effect, hyperconjugation and electronic effect. So electronic effect. Electronic effect. So what is electronic effect? Electronic effect is the permanent or temporary transfer or shifting or delocalization of electron. Okay, so it is the permanent or temporary transfer or shifting or delocalization of electron either in conjugation or from one atom to another atom or from one part of the compound to the another part, mainly atom. Okay, for example, we will see it is also dependent on the electronegativity, it is also dependent on the electropositivity. Okay, it is also dependent on the different types of bond which are present and the surrounding environment of the element. Okay, in this, so the main important point here, electronic effect is temporary or permanent. It is either temporary or permanent. In some cases it is temporary, in some cases it is permanent. For example, inductive effect is permanent, mesomeric effect is also permanent. Okay, now the most important point, what are the different types of electronic effect? Number one is inductive effect. Number two is mesomeric effect. Number three is mesomeric effect is also called resonance. Number three is hyperconjugation. And number four is electromeric effect. Okay, so today we will study the inductive effect first. After completion of inductive effect, we will go further towards mesomeric effect or hyperconjugation. Okay, so what are inductive effect? Inductive effect is mainly related to the density of electron. Okay, it is mainly related to the density of electron. How it is related to density of electron, I will tell you. First, you have to, before going to understand the inductive effect, we have to understand some small 2-3 points. The point number one is what is electronegativity. Electronegativity, because inductive effect is completely related to electronegativity and also polarity of bond. So first of all, electronegativity is the tendency of an atom to attract the electron. It is not the power, it is not the energy required to attract the electron. No, it is the tendency of an atom to attract the electron. Okay, tendency is most important. The same way electropositivity is tendency of an atom to lose the electron or remove the electron. Okay, now you know what is polarity and what is non-polarity. What is polar and what is non-polar? Okay, I will tell you another important point. You have to remember that the most important and the most electronegative element in the periodic table is fluorine. So you have to remember that fluorine is the highest electronegative atom in the whole periodic table. Okay, in the whole periodic table. So it is the boss. Okay, now see phone call. Normally in our house we use phone for Instagram, scrolling, Snapchat, snap sending, and chit chatting on WhatsApp groups and chit chatting with friends. Yes or no? But no, the phone was actually made for calling and conversation or transferring of information from one place to another. Okay. The phone is mainly used for calling, but we use for some other purposes, Instagram, Snapchat. So you have to remember phone is for calling. These phone and call are the high electronegative atom in the periodic table. Fluorine, oxygen, nitrogen and chlorine. These are the highly electronegative atom. Now I want to tell you that if this fluorine is present in any bond, for example this fluorine is connected with hydrogen, for example, okay, if this fluorine is connected with bromine or boron, in the case of boron, for example BF3, take BF3, in this BF3 fluorine are there, these fluorine are highly electronegative. When they are highly electronegative compared to boron, this fluorine has more electronegativity, that means it has more tendency to attract the electron. When this fluorine has more tendency to attract the electron, it will try to attract the electron towards itself. So ultimately what will happen? The electron density towards fluorine or electron density nearer to fluorine will be more. That's why it will be partially negative, it will also be partially negative, it will also be partially negative. Okay, partially negative means more electron density towards fluorine. So ultimately polar means, see, in this bond, normally if you take two carbon, these carbon have, both the carbon have same electronegativity. When both the carbon has same electronegativity, both of the carbon has equal amount of energy, not energy, equal tendency to attract the electron. When both have equal tendency to attract the electron, what will happen? The electron density will be equal in both the sides. At that time, the bond will be non-polar. That means the density of the electron will be equal in whole bond. Okay. But when you will take a bond which is present between two different electronegative atoms, in that case what will happen? For example, A, both the A have same electronegativity. In that case, this bond will be non-polar. But if you take A along with B, in that case A has more electronegativity compared to B. In that case, what will happen? This bond will be polar. Why? Because more electron density will be on the A side, because it has more electronegativity. Yes or no? When more electron density will be on the A side, this side will be little bit negatively charged, that is called partially negative, and that side will be partially positive. This condition is called polarity of bond. Okay. So due to the polarity of bond, what will happen? The induced, okay, for example, if this bond A and B has one bond, that is polar, if this B along with C connected and this B and C, or B is along with B, it is connected, this bond is non-polar. Why? Because both the B have same electronegativity. In that case, what will happen? This non-polar bond will be induced to be polar and induced by this polar bond. So this is inductive effect. Inductive effect is the induction of the polarity into a non-polar bond due to the presence of adjacent polar bond. Am I clear? Induction of or induced polarity to a non-polar bond due to the presence of adjacent polar bond. In that case, electron will not be shared, or electron will not be transferred, or electron will not be shared from one place to another place. What is called delocalized. Electron will not be delocalized. Rather, electron density will be delocalized. Okay. In the case of mesomeric effect, electron will be delocalized. In the case of hyperconjugation, electron will be delocalized. In the case of resonance, same mesomeric effect, electron will be delocalized. But in the case of inductive effect, electron is not delocalized. density of electron is delocalized, and due to which what will happen? Polarity, induced polarity in a non-polar bond due to the presence of polar bond on the adjacent side. This is called simply inductive effect. Now, if due to the presence of due to the presence of polar bond, if polarity is inducing, it can be induced in two ways. In one way, it can withdraw the electron density. It can decrease the electron density on B, and it will increase the electron density on, for example, this BF3. In that case, fluorine is trying to attract the electron density towards itself. So electron density will be more near to fluorine, and electron density will be less near to boron. Yes or no? This is called negative inductive effect. Whereas in another case, for example, if you take CH3, in that case what will happen? The electron density will be less on hydrogen, for example this CH3, and along with this CH3 is connected with carbon or carbocation. Then what will happen? This will try to donate the electron. This hydrogen will try to donate the electron. Why? Because the polarity will be there in carbon and hydrogen bond. Because this carbon is more electronegative than hydrogen, so electron density will be more near carbon. Again, due to polarity, the polarity will induce in the non-polar bond, and what will happen? The electron density will again try to move towards the carbocation. In that case, the electrons are this hydrogen are trying, or this alkyl group, that is CH3, is trying to donate the electron density towards the carbocation. This is called positive inductive effect, plus I effect. Whereas in the case of BF3 or any other electronegative atom, this will be shown by electronegative atom. More electronegative atom will try to withdraw the electron density towards itself. Why? Because of the more electronegativity. So electron density will be more towards electronegative atom, and electron density will be less towards less electronegative atom. So when electron density will be more towards more electronegative atom, ultimately what will happen? The electron density will be reduced in the central atom. In that case, it is called negative inductive effect. And when electron density will be increased, then electron density is increased in the central atom, it is called positive inductive effect. Am I clear? Now this positive inductive effect and negative inductive effect, both of them has a order, and you have to remember that order. One trick I will tell you, one hint I will give you, this is very very important. If you remember that hint, you can easily remember the order also. The hint is inductive effect is related to electronegativity. The one which will have more electronegativity, it will show more minus I effect, and the one who is less electronegative, it will show less minus I effect. Again, the one who is more electronegative, it will show less plus I effect. Why? Because it will not try to donate the electron, or it will not try to increase the electron density on the central atom. Why? Because he is more electronegative. More electronegative means try to take the electron density towards himself. So electron density will be decreased in the central metal atom or central atom. In that case, it will show less plus I effect. But if an element or if a compound or if a group is less electronegative, if an atom is less electronegative, it will show more plus I effect. Am I clear? Now the order is, you have to remember that order. Number 1, write minus I. Okay. So in this minus I, first of all, you will get bond OR2 positive. It will be more than bond NR3 positive. It will be more than NH3 positive. It will be more than NO2. It will be more than Cn, and it will be more than C double bond or COH, that is carboxyl group. Again, it will be more than X, it will be more than OH, it will be more than NH2, and it will be more than C6H5. C6H5 means phenyl group. Okay. Next you will see plus I effect. Plus I effect will be more shown by O minus. then after O minus, C double bond O, single bond O negative. After that, tertiary, hydrocarbon, then secondary, then primary, then CD3, then CH3. Okay, this is the order. The most important point you have to remember is that the most important point, write golden key points. Okay, so you can pause and you can note it down. Okay, now you see the golden key point, the most important point about the inductive effect. Golden key point number 1, that inductive effect is related to electronegativity. Golden key point number 2, electron density is involved, not individual electron, not individual pi electron. Number 3, most important point, put 5 star on that. That on increasing the distance, inductive effect decreases. That means you can say inductive effect is inversely proportional to distance. Next most important point, after 3 to 4 carbon, 3 or 4 carbon, inductive effect is negligible. Inductive effect is negligible. Next most important point, one of the foremost, that inductive effect of hydrogen is considered 0. Inductive effect of hydrogen is considered 0. So these are the golden key points. You have to remember that. Golden key points. Okay? Am I clear? Okay. Have you any doubt? If you have any doubt, please comment below. I will reply definitely. And class dismissed.